If you've been paying any attention to tech lately, you know AI is literally everywhere right now. But the real magic? It's not just about having massive data sets. The actual secret is happening right under the hood, baked into the very architecture of these neural networks. Today, in this explainer, we're demystifying exactly what makes this whole AI revolution possible.
Think about this for a second. We throw around the name ChatGPT all the time, right? But what does that T actually stand for? Well, it stands for transformer. And no, we are not talking about giant robots in disguise here. We're talking about a fundamental, incredibly groundbreaking architecture that completely unlocked how modern AI understands, maps, and processes data at a massive scale.
Let's start with part one, the flaw in older models and what we call the sequential bottleneck. To really appreciate why the transformer is such a game changer, we have to look at the massive roadblock that held back older systems, like recurrent neural networks or RNNs. They had a fatal flaw. They process data sequentially, meaning strictly word by word. Imagine trying to read a giant, dense book, but you're only allowed to look at one single word at a time. And you have to hold every previous word in your short-term memory just to figure out what the current sentence means. It's painstakingly slow, it eats up resources, and it just doesn't scale. Transformers? They strip all those recurrent units away. Instead, they use parallel processing, meaning they look at huge chunks of data all at once, which drastically cuts down on training time. So, how did we fix that? That leads us right into part two, Attention is All You Need, the huge 2017 breakthrough. Back in 2017, a team of researchers at Google published a landmark paper. Now, they were originally just trying to make machine translation a little better, like going from English to French more accurately. But in the process, they accidentally completely solved that sequential bottleneck we just talked about. They introduced something called the multi-head attention mechanism. It's actually a lot like being at a super loud, crowded cocktail party. There are dozens of conversations happening, right? But as a human, you have this natural ability to tune out the background noise and focus entirely on the person right in front of you. That is exactly what multi-head attention does for an AI. It contextualizes the data by amplifying the important signals and dialing down the less important stuff within its window. Moving into part three, let's break down how transformers actually process data, the anatomy of an AI. Let's walk through exactly how this maps out step by step. First step, step one, you start with your raw input data, so text, images, audio, whatever. In step two, that data gets chopped up into tiny pieces and converted into numerical sequences called tokens. Then, step three, the system takes each of those tokens and turns it into a mathematical vector by running it through this giant embedding table. And finally, step four, all those vectors get fed into that parallel multi-head attention mechanism we just went over, where the AI contextualizes all of them at the exact same time. But there's a bit of a technical catch here. Because the transformer is processing everything in parallel all at once, the self-attention mechanism by itself is what engineers call permutation invariant. Honestly, that's just a fancy way of saying the system has no idea what order the words are in. To the AI, it's just a giant, jumbled word soup. So to fix this, transformers have to mathematically inject positional information directly into the data. They use these things called positional encodings to guarantee that the actual order of the tokens affects the final output, which ensures the sentence actually makes grammatical, logical sense. That brings us to our final section, from text to everything else. Once the tech community realized just how wildly powerful this parallel processing could be, things moved incredibly fast. The architecture expanded into all these specialized variants, like decoder-only models for predicting the next word, which is exactly how modern chatbots work. Think about it. This was originally a system built just to translate text, yet today its versatility is just off the charts. It powers massive language models like GPT and BERT. It handles computer vision, audio, complex reinforcement learning, cutting-edge robotics, and yeah, people are even using it to play chess. The transformer literally became the universal engine for modern deep learning. Which brings us full circle right back to that legendary 2017 Google paper, Attention is All You Need. It was an absolute mic drop moment in the tech world. It solved a massive bottleneck and kicked off the entire AI boom that we are all living through right now. And it kind of leaves us with a fascinating question. With transformers already mastering so many wildly different fields, from writing code to controlling robots, what unprecedented AI capability is going to capture our attention next?